Hey kids! It's us! Murphy
and Foz!
This program has been brought to you by the letter Theta!
Oh no, the playback is getting all distorted!
Maybe the camera isn't working properly. I knew we should have bought another one.
But that was all we could afford with our budget! Maybe it's...
Now we'll never finish this episode on time.
No, wait, we will! I think I know a way.
What?
Well, right now we're using copper wiring to send signals for our playback, right?
Yeah, copper wiring that's been around since before we were born.
Well, copper wiring isn't that great for sending signals. We should replace them all with fiber optic cables. There's almost no interference, and they're cheaper.
Huh? What are fiber optic cables?
Why don't I demonstrate with an experiment? Good thing I always carry around my science kit and laugh.
The principle behind fiber optics is total internal reflection.
Total internal reflection happens when a ray of light hits a boundary between a more optically dense material, like this plastic block, and a less optically dense material, like the air, in this case, at an angle greater than the critical angle. Look, the light is completely reflected back through the plastic block. None passes through.
But we still don't know what fiber optics are. How is this related?
Well, what happens in fiber optics is that a beam of light, usually from a laser, is directed through a very thin glass cable, only 9 to 63 microns across. That's thinner than a human hair. The light travels down the cable according to the principle of internal reflection, bouncing off the sides of the glass. Kind of like when I shine this light through the stream of water, the light comes out the other end.
Wow! But how do fiber optics carry signals that can be used for TV?
Different pulses of light are sent through the cable by a transmitter. A light detector, usually a photocell, detects these pulses of light at the end, and can turn this back into images and sound. These signals can travel thousands of kilometers, and they travel very fast, at the speed of light.
Don't some of the signals get lost?
Well, some of it will. Usually, there are several laser amplifiers called dopings that can help prevent this. Doping is a special coating that uses the incoming light energy from the beam to emit a new, stronger signal.
That was informative. What do we do now?
Well, luckily, we keep fiber optic cables everywhere, so let's replace all the copper wiring.
Okay!
Now that we figured all this fiber optic stuff out, time to put it to use. Cue commercial!
Fiber optics, because they're pretty to play with.
Fiber optics, because they are flexible and can transmit light, therefore can be used in endoscopes.
Fiber optics, because they light up my Christmas tree. Ho ho ho.
Fiber optics, because they transmit clearer pictures and sounds for our viewers.
Fiber optics, because they make mechanical images to guide me around the sewers.
Fiber optics, because they help trains communicate. Fiber optics, because they have so many advantages.
Have you ever heard of fiber optics, Murphy?
Of course! That's what polar bear fur is made from. That's why they're so sparkly.
No, that's just a myth. Polar bear fur just scatters light because the hair is hollow.
But so are fiber optic wires, aren't they?
Silly! Fiber optics are made of pure glass or plastic.
Cool! So I can see through it?
You shouldn't do that either. Laser light can harm your eyes if you look at it.
So I'll get blind?
Not necessarily, since light intensity would decrease with distance, but it's never a good idea.
Then what would happen if I poured a cup of water on it?
Nothing much. To actually harm a fiber optic wire, you'd need a flaw, tension, and moisture on a large scale, so you'd probably need a lot of water.
What if I ran over it with a truck? Since fiber optic wires are made of glass, they're fragile, right?
First, you can't drive. And second, they're pretty sturdy. People have done that and no significant damage has been seen. It's not recommended at all, though. But speaking of which, why are you being so destructive?
I'm just...
Good thing I always carry around my science kit.
Yeah, that's good. Cut. Okay.
Cut.
You have to interrupt me.
Cut. Maybe the camera isn't working properly.
But speaking of which, why are you being so destructive?
I'm just... I knew we should have bought a new one. I knew we should have bought another one here, right?
But that was all we could afford with our budget.